Good morning, students. I welcome you to the update teleconferencing session on operations management, and today we will be discussing about quantitative techniques, which basically entails the course MS8, and it is generally believed that this course is a little difficult course for those students who does not have a background in mathematics or statistics. And since in the management program we have students from diverse backgrounds, it's not necessary that everybody has a background in mathematics, especially up to 10+2 level. So in short, this course poses little problems for the students in terms of the understanding. Normally people get scared by the use of extensive mathematical techniques that are involved in this course. What I'll be discussing in the two sessions that we have on operations management is importance of quantitative techniques basically in managerial applications, and then I'll be taking you to a very important and basic concept in quantitative techniques, that is the sampling distributions. And I'll highlight basically why understanding of sampling distribution is a essential thing for your understanding of quantitative techniques. And once you understand the sampling distributions, the quantitative techniques and testing of hypotheses kind of activities would be very easy for you. So let me begin my presentation by taking up the topic of importance of quantitative techniques in managerial applications. In the next session, that is from 12 to 12:45, I'll be taking up sampling distributions, and that will make the update TC session for today. Right. So I would like to start from a small narration of what used to happen in yesteryears. In yesteryears, there were no computers or computing machines. So what people used to do was they used to keep records either by remembering them or by making small notes, which in Hindi was called pothi or bahi khata kind of a thing. So they used to make small notes of those things, and normally the operations were not as big as it is today, in the sense every business used to cater to a small population, which is basically a local population in the neighborhood. So there were very less international trade or big operations in those businesses in the yesteryears. What was special about this was there was no competition, in the sense if there was a seller in a particular neighborhood, since there were no modes of transport, people would not be able to go to far off places, so there is no competition to that particular seller. Basically people will have to buy things from that particular seller, so there was no competition. Then he need not market his own products, because he will be having some kind of products with him, and people would know that these products are available with this particular seller only. So it was not like today that he has to make advertisements or he has to make some marketing campaign to advertise his products. That was not required in yesteryears. Then finance records are not basically written. What he used to do was he used to keep all the currency, all the money that he is getting into a kind of a safe, which is called tijori, and no HR records or personal records, or not even nothing like a management information system, because the owner of a business used to remember all the grievances, all the problems of his employees, and he used to be just like a family to the employees. So this was what was happening in yesteryears, and if we talk of today's business, things have changed very rapidly, and I'll just highlight 2-3 points of pertaining to those changes which have occurred in today's business environment, and these changes are like this. Now, you have to react to these changes which are occurring in modern business in a very short span of time. You require decisions with long-term implications, because if you are not ready, then you will not be able to seize the opportunity that the business is providing you. So what is essential in today's business environment? That you use information, you make decisions on the basis of some kind of information, and you get ready for the future. So what the businesses are doing at this moment, they are collecting lots of information. And what is this information? In what form it is? It is in the form of data. So what they do, they analyze this data. So basically they analyze information and learn lesson for the future from this information. And precisely the analysis of this information or this data is done with the help of quantitative techniques. So in a nutshell, quantitative techniques allow you to analyze information and learn some lessons on the basis of that analysis, and use those lessons for your future planning and for your future work. So this is how this is the business cycle of information, in which quantitative techniques help basically the decision maker to analyze and take inference from those analysis. Now, quantitative techniques can be divided into two categories. You can see these categories on your screen. These categories are statistical techniques and operation research techniques. And if you remember that we have two courses in the operations management stream. These courses are MS8, which is pertaining to the first category, that is the statistical techniques. And then in the operations management stream, we have got an elective which is MS51, and that pertains to the second category, that is the operation research. Now, what entails quantitative techniques? What is included in quantitative techniques? It is the numbers, symbols, or mathematical formula. That means the expressions or equations are used to represent the models of reality. What does this mean? That you have found a relationship from the data. That relationship is basically expressed in the form of an equation. And how do you form an equation? You use numbers and you use symbols and put them together, and you call that a equation. Say the revenue or the profit of a company is dependent upon the quantity of a particular item that is sold by the company. So suppose my equation of this relationship comes to be P is equal to 3Q plus Q square. What I am suggesting here is that my profit is dependent on the quantity sold, which is represented by Q, and the relation between these is that it is 3Q plus Q square. Now, if I say that I sell one object or one number of quantity, so what will be my profit here? My profit will be 3 into 1 plus 1 square. That means I'll make a profit of 4 rupees if I sell one item of that particular quantity. And how I am able to calculate this amount 4? It is with the help of the equation that I just narrated. So quantitative techniques basically simplify the process that exist in real life situations. So we say that basically they are expressions that show models of reality. Now let us move further and try to define what we mean by statistics. There are several interesting definitions, and you can see them on your screens. That it is Benjamin Disraeli who has defined statistics as there are three kinds of lies: damned lies, and statistics. I'll discuss these definitions. Let us read the next one also. Darrell Huff has given an interesting article, How to Lie with Statistics. Crooks already know these tricks, honest must learn them in self-defense. Now, these are two definitions of statistics on the lighter side. Basically, statistics or quantitative techniques allow you to play with the data. Now, you can analyze data in several ways, and generally statistics is accused of deriving that kind of inference that is suited to the researcher or suited to the business person. And it is very easy to do it, because since there are so many ways of analyzing the data, one can very easily write an inference which is basically suiting the decision maker, but actually it is giving a biased figure. You can make several inferences, all of them would be correct, but as per the normal language it will be biased towards one particular thing. Now I can give an example of this, that suppose you are setting a confidence level of say 95%. Now your hypothesis is getting rejected at say 96% or 94%. Now if you keep the inference level at level of significance at 95%, you will be rejecting that particular hypothesis. But if you keep it at 90%, you will be accepting it. Now both these inferences are correct, but you can report them in two different ways. One way is that you accept the hypothesis, the other way is that you reject the hypothesis. So this is how statistics can be used in conflicting situations. Let us go a little bit in the history of statistics. In fact, the word statistic has come from the Italian word statista, and statista means statesman. It's an Italian word, it means statesman, and the word statistics was introduced by a mathematician called Zimmermann. In London, in United Kingdom, it was used in the first place, and in fact there is a little story about this, that the King Henry VII fear of plague forced England to register its dead in 1952. This is the basically first usage of statistics. So English government started publishing these figures, and these were called bills of mortality in late 1500. So there was a person called Captain John Grant who used 30 years of bills of mortality to predict that number of people who would die of diseases and the proportion of expected male and female births. Now it has started from a year as old as 1500. So basically how it was started, that people started collecting some kind of data. In this case it is bills of mortality, and they used to analyze these bills of mortality to predict the expected number of male and female births and number of people who would die of a particular disease such as plague. So this was the history, and this was the start of usage of statistics in everyday life. Now this is a very interesting definition that I'm going to give you right now of what different people think about statistics. It's a very, very interesting definition because there could be thousands of definitions of statistics depending on the person who is using that particular statistical technique or who is using that particular data in a particular circumstance. Now if I am a hockey coach, for me, chance that Germans will use 3 deflection methods for the penalty corner would be statistics. So what will be my data here? My data would be all penalty corner kicks that were taken by the German team. So I'll find probability that what is the probability that they have used the 3 deflection method for the penalty corner. If I'm a manager of a production factory, then amounts of pollutant released in the atmosphere by my company would be one of the things in which I'll be using statistics. If I'm a food and drug administrator, then undesirable effects of a new drug on general people would be statistics for me. If I'm a bank and I'm giving loans to people, a particular person would pay the loan on time would be statistics for me. And as a student, your grades in the term end examination would be statistics for you. So by this, what I have explained here is that different people have different meanings for statistics. It is basically the kind of data they are using and the kind of decision they want to make, which gives rise to the statistical techniques and statistics. Now, statistical data can be defined as some sort of statistical data. And why we are using statistical data here? Because we want to link data with statistical techniques. So data could be of any kind, but statistical data is that data that is capable of being handled by statistical techniques. And being handled means being analyzed. It can be analyzed with the help of statistical techniques. Then it is called the statistical data. So basically it is a numerical description of quantitative aspects of thing. Suppose I am talking about students, I can talk about the height of those students. I can talk about the intelligence quotient of those students. So what I am doing here is that I am assigning a number to a particular trait of that particular student. So one particular characteristic I am measuring by a particular number, and this is what the statistical data is, that I am using a numerical description of a quantitative aspect of a particular thing. Now this description can be in form of counts or in terms of measurements. Say if I give an example of counts, I would say that number of white color cars passing from a particular T junction in 1 hour on Sunday. So basically what I am doing here is that I am counting the white colored cars that are passing through that particular T point in 1 hour time on a particular day, that is Sunday. So this is my count data. The other kind of data could be a measurement, and what example I can give here is that the speed of white colored cars passing through that T point in 1 hour on a particular day. So here what I am doing is that I am measuring the speed of those white colored cars that are passing through that particular T point. So I can divide data into these two categories, And we can have further divisions like you must have heard about the nominal, ordinal, cardinal scales and the interval and the ratio scales. So nominal is what that only two alternatives are there. So data could be in the form of either yes or no. Then you could have a category, say 5-point category, very good, good, average, bad, very bad, that kind of category you can have. Then you can have a ratio scale in which say you measure temperature on a thermometer, and those values are basically ratio scale values. And you can have a interval scale values, which is a common measurement that we were talking about. Let us move further and classify statistical methods. You can see the graphic on your screens. Basically, statistical methods can be classified into these 6 categories, and basically these are phases of statistical investigation. So you start with collect, and that is the topmost bullet, and you move clockwise here. From collect you go to organizing the data, then you classify the data, interpret, analyze, and present. In fact, analyze should come before interpret. So classify, analyze, interpret, and present. So basically statistical methods are can be put in these phases. So once you collect the data, you move on to organize it in a particular manner. Say you make an Excel sheet of that particular data, then you classify it, you arrange that particular data in either increasing order or decreasing order, and you move various columns from one place to other place. After that, you use some kind of statistical program to analyze that data, and there could be several programs like SPSS or Minitab and things of that sort. And finally, after analysis, you make interpretations and you present your interpretations. Now there are some characteristics of data which you should know. These characteristics are: data must be aggregate of facts. They should be affected by multiplicity of causes, could be estimated with accuracy, could be collected in a systematic manner for a predetermined purpose, should be comparable, and should be capable of mathematical treatment. Now, let us discuss these points. If you have a data which is not changing with the times, if anything happens, there is no change in particular data, then that data is useless for you. Suppose you want to, you're talking of sales of a particular product. Even if you reduce the price, you increase the advertising campaign, or you do any kind of popularization activity, but the sale is not increasing, then that particular data is of no interest to you. So data should be affected by external factors, and that is the second point. What are these external factors? The ones that we have discussed right now, that if you give a price promotion, then sales are bound to increase. Similarly, there are several kind of factors that would have an impact on sale of a product. So this is one of these important points. The other thing is that if you have similar data about one particular characteristic on many companies, then you should be able to compare it. If you are unable to compare, then there is no point in collecting that particular kind of data. So data should be comparable. That is another important point. And the most important point is that it should be capable of mathematical treatment. Because if it is not capable of mathematical treatment, then what kind of analysis would you put and try to analyze your results. So basically, mathematical treatment is a must if you want to talk about quantitative techniques. So these are some characteristics of data. Let us move further and describe the types of data. What are the various categories under which you can collect the data? Basically, these categories are secondary data and primary data. And what is secondary data? That is a particular data that you collect from secondary sources. And what are these secondary sources? They are published data. It is collected by some other agencies like World Bank, United Nations, ILO, census, trade organizations, etc. So secondary data is basically that particular data that is collected by a different agency for a different purpose, and it is published. It is published either in the paper form or through the World Wide Web. And as a researcher, as a business person, you use that particular data or a part of that particular data for your own purposes. So if you analyze this kind of data or you collect this kind of data, this is called collection of secondary data. Now let us move on to the primary data. And what is primary data? That is collected by the researcher himself to make investigation into the kind of problem that he is dealing with. So the basic difference here is that primary data is basically collected by the researcher himself. Now data can be further divided into two more categories, which is micro data and macro data. And this is the last bullet in this slide, that micro data is for a particular unit and macro data is for the entire country or organization or economy. And we can take examples of this. The census that is done for a particular country, population of a country, that is a macro data. And suppose you want to check the number of defects in a particular product that you are manufacturing, that is a micro data. Let us move further and discuss about the categories of statistical methods. And this basically gives you everything that you will be reading or you have read in this course MS8, which is Quantitative Techniques for Managerial Applications. Now you can see that statistical methods can be divided into three categories, major categories. One is descriptive statistics, then inductive statistics, and statistical decision theory. This can further be broken down into categories like in descriptive statistics we do data collection and presentation. In inductive statistics we are into statistical inference and estimation, and in statistical decision theory we are into analysis of business decision. Now if you refer back to the course content of the Quantitative Techniques for Managerial Application course, you would see that first two blocks are dedicated to the descriptive statistics. Alright, the third block is basically on probability, that makes a basis for the subsequent blocks to come, and basically for inductive statistics, in which we talk about statistical inference and estimation. And it is the probability theory which forms the basis of this, and we'll see the application of probability in the next session when we talk about sampling distribution. So what I was talking about is that block 3 pertains to understanding of probability distribution, whether discrete or continuous, and then block 4 moves on for sampling distribution, testing of hypothesis and things of that sort, and the last block basically pertains to analysis of assertion regression, and time series. So this makes the entire course of quantitative techniques for managerial applications. Important thing is that inductive statistics, in fact, is the most popular category of quantitative techniques because it deals with many problems, many activities in which it provides solutions to various kind of problems that are found in modern day business. Descriptive statistics is good when you have simple kind of data and you put them in form of tabulations or cross tabulations, and you need not further analyze it because that relationship itself is visible by the table itself. But if you want to find something that is not visible in the tabular format, or there is a hidden relationship, then you have to take the help of inductive statistics and statistical decision theory basically. So let us see what is meant by statistical decision theory. Statistical decision theory is basically a set of tools that deals with analyzing complex business problems with alternative strategies and possible consequences. You must have seen a decision tree, and what we do in a decision tree, that we start with a particular problem. At each step, what we try to do is that we try to have all the possible alternatives, and we keep on moving on the basis of those alternatives that are available to us. So what we try to do is that we try to branch out a particular problem. And how do we branch out it? We write all the alternatives. So we start with one statement, we write all the alternatives of that particular statement, and for each alternative again we write down all the alternatives. So it is sort of branching out. You must have seen a tree, and what happens there, that from one branch there are several other smaller branches that are coming, and further, and it goes like this. So a decision tree approach is that you write down all the alternatives, and finally you present a picture as to if this happens, what will be the next thing that is going to happen. Now, the basic purpose of doing this kind of exercise is that you are willing to find out the best course of action for that particular business problem. You want to find out that if I follow this particular set of alternatives, what will be the effect of these alternatives on my business. And once you do this kind of exercise, you try to find out the best course of action in that particular situation. So these kind of problems are tackled by statistical decision theory. Let us also discuss the states of decision when we are talking about statistical decision theory. Now, there could be 4 states of decision. One is certainty, other is risk, third one is uncertainty, and conflict. And what are the consequences of a certain decision? That it is a deterministic event. If it is a risk that is involved with a particular decision, then you would say it is probabilistic. If the thing is uncertain, then you would say that it is unknown consequence. You do not predict about the consequence, or you do not know about that particular consequence. And conflict, when your opponent is influencing you or your work. So basically, statistical decision theory uses probability, subjective or prior, and it is also called the subjectivist approach or Bayesian approach. And why it is called Bayesian approach? Because it is named on popular statistician, which is Bayes, and you must have read about the Bayes theorem, the popular Bayes theorem in probability. So Bayes theorem basically deals with prior and posterior probabilities, and it is having a very good application in the business world. Now let us go back to the states of decision that I've mentioned just now: certainty, risk, uncertainty, and conflict. Now, what kind of decisions are generally found in business? It is uncertain, it is risk oriented, and it is conflict. And I'll try to give examples of each of them. But definitely certainty kind of decisions are not found in business. You cannot say that if I do a particular price reduction, my product will sell these many units more. No, this is not possible. So basically it is a kind of a risk, a calculated risk that every business has to take. And on what basis it will take? It will use quantitative techniques to analyze that particular situation and calculate that particular kind of risk involved and go ahead with a particular decision. So example could be, I want to reduce the price of my product, but the risk involved is that the revenue of my company would go down. The other risk involved is that my competitor will also reduce the price, so I may not get